Hi everyone, this is Veronica. Today we are going to talk about space technology and how is it useful for the agriculture in our country. We are an agriculture based economy majorly. So we'll talk here about the agricultural distress and how we can use space technology to mitigate our agricultural program, policies and help the farmers. So for my video updates, you can follow me on Instagram and Facebook. The PDF of this lecture will be uploaded on our website. So this is our channel StudyIQ. If you're preparing for any government exam, our pen drive and tablet courses are also available. For additional information, you can call on these numbers or you can visit our website also, and the PDF will be uploaded on this website only. So now from exam point of view, what is the relevance of this topic? So this topic will be covered under your mains paper 3. I am talking here from the UPSC perspective, agricultural technology in the aid of farmers. And from objective level, various initiatives you should know what government had taken earlier to use space technology to mitigate the problems of our agriculture. And at subjective level, various technological measures for enhancing farm productivity. So you can mention this topic here. So now why it is in news? Because the Ministry of Agriculture and Farmers has been proactive in using the space technology in agriculture sector. So we will talk here about various initiatives in the aid of farmers. So firstly, if I talk about some of the institutional measures, so first is here the Department of Agricultural Cooperation and Farmers Welfare, they have established a center which is known as Mahalanobis National Crop Forecast Center. And who was Mahalanobis? You should know that he was a very famous Indian statistician, PC Mahalanobis. So this center has been opened by Indian government. They have opened it in 2012 in the collaboration of ISRO. So here they are using this remote sensing technology and they are doing what is this used for agricultural forecasting. So it works for operationalization of the space technology developed in the ISRO for crop production forecasting. So forecasting here plays a very important role that is specific to the crop production. So they also do other things here also, like drought assessment is done. They use the satellite technology. They study the current and past trends. Then multiple forecast is done of around 11 major crops which include both Rabi and Kharif crops, and they use remote sensing technology and GIS. GIS is your geographical information system. So here I'm again and again using that in space technology. One technology we are prominently using, that is remote sensing. So you should know what is remote sensing. So I'll write it here. See, here we are using in remote sensing, we are using satellite or aircraft based sensor technology to detect and or classify the objects on earth, whether they are oceans, agricultural or atmospheric objects. So there is one active remote sensing, that is when a signal is emitted by a satellite or aircraft and its reflection by object is detected by sensors. And other is passive remote sensing, that is reflection of sunlight is detected by the sensor. In that case it is known as passive remote sensing. That is how we are using space technology. So all the data that is captured by these sensors to this remote sensing technology is analyzed later by these centers. So here this center is one of the major institutional measures where we are using the space technology. Now this slide is very important because here we'll talk about how are we using space technology, what are the different initiatives or particular projects that have been initiated by the government of India. So firstly, as I told you, we are using the space technology to for crop production forecast. So by forecast I mean we are studying the magnitude of yield. So yield here is very important, or what is called production of the crop. So it is majorly done in two ways. Firstly, the estimation of area under crop is done, and then the yield per unit area is measured and this is multiplied. This gives us the crop production forecast. Now the very first project that was launched in our country was Fausle Project. So what is Fausle? Forecast agricultural output using space agrometeorological and land based observation. So this is the expansion of Fausle Project. So this project was started in 1988 by Government of India. So before this project they started, actually the original project was CAPE. So CAPE is crop acreage and production estimation. So they had to collect statistics of agricultural output. So there met this problem and they needed weather information, because weather information for agriculture is very important. Next thing, they need various other things like information about economic factors also, but for weather information that was needed in the CAPE project, they launched this Fausle Project. So their main aim here was to collect the monsoon data. Monsoon data is very important. Like in our country, we majorly depend upon the monsoons only. So to collect monsoon data through remote sensing and economic data, they have launched this Fausle Project. So here we are using remote sensing only. So this is one example of one initiative where space technology is being used for the agricultural sector. Now the next is your Chaman project. So Chaman project is for the development of horticulture sector. So here it is specially for horticulture sector. So what is horticulture? This is basically the garden cultivation or floriculture. It is used usually for food, comfort or beauty. So in horticulture, what is grown? Your fruits are grown, nuts are grown, vegetables, ornamental plants are grown, and this is very important for the farmers because this is very commercial in nature and it increases the income of the farmers. So this using remote sensing in Chaman project was it was one of the pioneer project in the horticulture, where we were using remote sensing to increase the income of the farmers, and we were here using the waste areas. So through remote sensing, so suppose this is the earth and there is a satellite, remote sensing satellite. So it is sending signals, it is taking photographs of the earth, it is studying it through the sensors, how these emitted radiations are reflected back. So all the waste areas were identified, and horticulture was we were doing horticulture on those areas. Now the last one is your NADAMS. So NADAMS is your National Agricultural Drought Assessment and Monitoring System. You can see here National Agricultural Drought Assessment Monitoring System. So what it does, it prepares fortnightly reports on the droughts by using advanced wild field sensors or satellites. So here the satellites we're using like IRS-1D, IRS-1C, 1D resource satellites are basically using. So we are planning and drought declaration process is done. So basically using space technology in agriculture is an integrated method. So not only we depend upon the space technology, however it is a major step here, but manual collection is also done. Then the analysis report is made ready for the farmers and crop insurance like activities take place. So when we are talking here about the crop insurance, so the space technology here helps us getting fast and unbiased information about the crop situation in the country. So this is how space technology is helping us, and it is providing us digital data which is amenable to various analysis. So because of its synoptic view, it provides images of the whole country in a short duration, and this data that we are collecting through remote sensing, it could be used for various programs which need information on crop type, crop area estimates, whether it is about crop condition, damages, growth or etc. Now latest project which was where we were using space technology was a Kisson project. It is an acronym, and here I have written with the red color. You can see for K it is for crop, I is for insurance, S is for the space technology, and geoinformatics. So this project was launched in 2015. This project has envisaged use of high resolution. So here we are using high resolution remote sensing data for optimum crop cutting experiment planning and improving yield. So under this project, pilot studies are also conducted in 4 districts of 4 major agricultural states like Haryana, Karnataka, Maharashtra and Madhya Pradesh. And thus study provided many useful inputs, like for smart sampling, how could smart sampling be done, what is the yield estimation, what is the optimum number of crop cutting experiments. So these were used to define SOPs. SOPs are your standard operating procedures for use of satellite data in revised guidelines of Pradhan Mantri Fasal Bima Yojana. So here you can understand that yes, space technology is helping. To conclude, you can say it is helping us a lot. Like agricultural forms the basis. So agriculture is the basis of food supply in India, in even in the world. So soil conditions, water availability, weather extremes, and climate change can represent costly changes both to the farmers and overall food security of population. So when we are using space-based technology, value to farmers, agronomists, food manufacturers, and agricultural policymakers who actually wish to simultaneously enhance production and profitability. Therefore, remote sensing satellites provide us key data for monitoring soil, snow cover, drought, or crop development. Even rainfall assessments from satellites, for example, they help farmers plan the timing and amount of irrigation they will need for their crops. So accurate information and analysis can also help predict a region's agricultural output as well as in advance, and can be critical in anticipating and mitigating the effects of food shortages and famines. So now you understand the role of space technology in agricultural sector. So here is a question for you, because obviously in prelims it is very important about the various initiatives of government that I have talked about, and here is a question for you that you can practice. Examine how can India's farm sector benefit from space research technology. So we have discussed it. You can practice writing here. For my video updates, I already told you can follow me on Instagram, Facebook, and if you have any query, you can contact me on my social networks. Thank you.